those others. And it really doesn't matter which one you use, both of those work all the time. Quadratic formula is possibly a little bit nicer, but they both have their benefits. The last portion we're talking about today are inequalities. So we're going to be talking about quadratic inequalities. And what I have up here are just a lot of graphs. It's up to you if you want to draw these or not. But we're going to be solving some quadratics and looking at the graphs to answer questions to inequalities. We know parabolas can be upside down or upwards, right? When I'm looking at this, if I asked you on this first graph, where is your graph greater than 0? Is that the blue part or the green part? Blue. The blue, the greater than 0. And so for this one, if I were telling when it was greater than 0, I would have two intervals, wouldn't I? Because this is coming from negative infinity, stopping at A, next one starting at B and going to infinity. If I asked where this graph is less than 0, where would it be? The green. So it's just from A to B, just one portion. Now if I flip that, now where is it greater than 0? Yeah, just between A and B. Where is it less than 0? Right. So you have to watch. You're either going to get one interval or you might get two separate ones. And it's going to depend on a couple things. Which direction your parabola is facing, and if I ask for the greater than or less than 0. You might have a case where it actually just touches the x-axis. So this parabola is always greater than 0. Greater than or equal to 0, I guess I should say. This one is always less than or equal to 0. Or I might have a case where it doesn't hit the x-axis at all. So this one is always greater than, and that one is always less than. So we're going to have to watch a lot of different things on this. We're going to have to pay attention to, am I asking for greater than or less than? Am I talking about equal to 0 or not equal to 0? And then how does that equate to the graph? So the first part will be the same. We will solve these quadratics, factoring, box method, completing the square. However, then we'll use the graph to answer the final piece about the inequality. And we will be giving intervals on our answers. Okay. So let's just start solving some inequalities. So on this one, at the beginning, we're just going to pretend that wasn't equal to 0. And we're going to solve it like normal. We always try to get 0 on one side, everything else on the other. If it works, box method is going to be your easiest and fastest option. So can I do box method here? Yeah. It's a 1x squared, so I can even do the shortcut. Multiply to negative 12, add to negative 1 would be negative 4, positive 3. And then you just keep your inequality. Okay. You have to be careful. If you just say x minus 4 is less than 0, maybe, and x plus 3 is less than 0, you're going to get the wrong answer. Because if less than 0 means negative, right? If you take a negative times a negative, what do you get? Positive. A positive. So can both of those things be negative at the same time? No. It means one could be negative and one could be positive, or vice versa. So the easiest way to figure this out is to use the graph. Now I'm going to draw just a really rough sketch of the graph. And what I want to know first is, when will this equal 0? What makes x minus 4 equal 0? And what makes x plus 3 0? Okay, so my really rough sketch, I want you to plot those points. So I'm hitting the x-axis at negative 3 and positive 4. We are going to use our graphing calculator for the next piece. So go to your calculator. You can plug in You could do the factored one. I prefer to always plug in the original. It helps me catch any mistakes that I might have made along the way. So I'm going to go to my y equals. I'm going to type in x squared minus x minus 12 and look at my graph. If your graph has a funny window, you might hit zoom number 6 if you need to reset anything. So what's our parabola look like? Yeah. And we kind of knew that already, didn't we? We know enough about parabolas. We know that this was a positive x squared, so it should be opening up. And I knew these were the two places where it equaled 0, so I didn't really need a calculator because I know enough about them already. I want to know when this is less than 0. So is less than above or below? So how many intervals am I going to have? 1. Okay, can it be equal to 0? No. No, so my intervals will have parentheses, not brackets. So this one starts, what was this point where it equals 0? -3, and it ends at 4. So that tells me any number between -3 and 4 would make this original thing less than 0.
So why did we have to go through the whole process of graphing and not just realize that -3 would come first?
Because if this had been greater than 0, your answer would have been negative infinity to -3 union 4 to infinity. So it's just kind of that visual so you can see which part of the graph we need. Other questions? Let's look at this one. So first step, start with our box method. X squared breaks into x. Since it's just a 1x squared, we don't have to draw the box. Multiply to -15, add to -2. Okay, so first from here, we need the two things that make it equal 0. What makes x minus 1? Now we need to graph. Now, I could use my calculator, or we could use our knowledge about quadratics. Does this one open up or down? It opens up, so we know it's got to look something like this, right? Without finding the actual spot of the vertex and all those pieces that we've done before, because I don't really need those. I just need to know the general shape. Now, of course, if you graph it real quick, if you went and you plugged in x squared minus 2x minus 15, does that give you a graph similar to what I just drew? Yeah, close enough. It gives us the important pieces. Okay. What did I want for my answers? Above or below? Less? Yeah, less than is below, but we have to include 0 this time, so we will put a bracket starting at -3 and ending at 5. Questions on that one? Do you have a question?
I said this is too easy. There's definitely going to be a
You have no faith in me. Okay, let's do another one. First step, you always want to make sure it's equal to 0, which it is. Then we need to,
Get rid of our 2.
okay, so this 2 is preventing me from doing the shortcut box method. But I could try to actually draw the box, couldn't I? And then if that doesn't work, we could get rid of it and do like completing the square, or we could do the quadratic formula. We have lots of options. So 2x squared negative 12. So multiply to negative 24, add to positive 5. Negative 3. So factor 2x squared and 8x, you can take out the 2x. Negative 3x and negative 12, you can take negative 3. 2x squared minus 3x, pull out the x. 8x minus 12, take out a 4.
So do we have to actually solve this?
Yeah, I need to know the two things that make it equal 0, just so I have those points on my x-axis. So that is 3 over 2 and negative 4.
Would we still be able to put it equal to 0 like that if it was open?
Yes, you'll just, the open or closed will be on your final answer when you set parentheses.
So that doesn't matter if you're
Right, you will
solving.
always set it equal to 0, just to find those numbers on the x-axis. Okay, open up or down? Up. Really, almost all these are going to open up, because if I had put a negative here, what would you have done before you did the box method? Right, you would have multiplied by a negative 1. So really, by the time we get to the end, they're probably all going to be facing up. But you do have to watch, if you multiply by a negative, what happens to your inequality? It flips. Okay. So you could graph it on your calculator if you needed to, but we know positive x squared should look like this. Something like that. My graph is a little skewed. But it tells me the important pieces. Did I want above or below? Above. So this time I will have 2 pieces. It had to equal to 0, so we have to include brackets. So the first piece, you're listing the x values. This is coming from ending at
Bracket
union.
1, 2 over 3 over 2.
We have the bracket, comma, and then these always get a parenthesis. Yes, ma'am. Are you sure?
Yeah, I was like, where's the
Oh, okay. Did you find it?
Got it.
All right. Why don't you guys try this one on your own? So we have to do the full box method. Multiply negative 12, add to negative 11 would be negative 12x and positive 1x. Factor 3x and 1, x minus 4. Have to set each piece equal to 0, and you get x to be a negative 1/3 and a positive 4. We know it opens up, so it should look something like that. I wanted greater than, so that's the positive, so 2 pieces. Didn't have an equal to, so everything gets a parenthesis. So it should be negative infinity to negative 1/3, union 4 to infinity. Any issues with that one? Alright, let's do... I'm gonna do a few more before we wrap up. What do you mean?
So, when it's less than, it's always gonna have 2 answers.
If you first make this x squared positive, so you have just a regular upward parabola, if that's your first step, then greater than will be 2 answers, less than would be 1 answer. Unless you have a scenario where you had a quadratic that only hit the axis 1 time, or that didn't hit it at all, and then it could change. And that's what we're getting ready to look at. But in general, most of the time, greater than will have 2 answers and less than will have 1. Okay, on this one, what do we need to do first? Yeah, we can't do box method with a negative x squared. So if I take everything times a negative 1, what happens?
Flip your sign.
Okay. Now we can try box method. Multiply to 15, add to negative 1. Doesn't work, does it? Okay, so what else can I do? Okay, can we do the quadratic formula?
Yeah.
Figure out when it's equal to 0? Let's try that. So this is the formula I asked you to memorize. X equals opposite of b, so positive 1, plus or minus the square root of
B
B
squared
squared
minus
4,
4
then
times
A, and
3
C.
times 5 over 2A.
good.
Good job.
So under here I get 1 minus 60. What's wrong with this?
It's not.
It's just wrong. There's a negative.
There's a negative. So what kind of number is this? Imaginary. When you draw and plot points on the x-axis, do we plot imaginaries?
No.
No. So what this tells me right now, these are imaginary numbers. So there are no x-intercepts on this graph. It never hits the x-axis. Let's graph it and see what it looks like. We could graph either one. Let's just go with the original. Let's graph that real quick.
Wait, so it has no x-intercepts because it's a negative.
Because it's a negative under the radical. So I could go ahead and solve it and get imaginary answers, but that's not going to help me in terms of drawing a graph. So I'm graphing the original one right now.
The negative.
Yeah. You could really graph either one and you'll get an equivalent answer, but I'm just going to graph this one.
Why is that not okay?
Mine says mine was an error. Because mine just worked.
You should get a graph that looks like this.
Why is that not okay?
Oh, yeah.
Well, it's okay to have an imaginary, but you can't draw an imaginary number on the x-axis. So what it tells us is we have a graph that never hits the x-axis. So I'm just trying to see where it's at. You put a minus instead of a negative sign.
Why does that matter?
Okay, so we can see this graph never hits 0. If I graph the original said greater than 0. So if I'm looking at this, when is it greater than 0? Never. So what's my answer?
No solution.
I said that about 5
Okay. Is that one alright?
Yep.
So look at another one. Yep, we are. We need a 0.
And then it's gonna be negatives, then we're gonna have to get rid of our negatives.
Okay, so she said subtract over your x squared. Can I just rewrite this as negative x squared plus 2x plus 4?
Yes, you can.
Okay. And then you said you don't like the negative, so how do I fix that?
You don't have a negative one.
Which does what? Okay.
Makes everything okay. Now we can do the good old box.
Box method. What multiplies to negative 4 and adds to negative 2? Oh. Never mind. Can't do box method. What can we do?
Why didn't you do the?
Nothing multiplies to negative 4 and adds to negative 2. We could also do complete and square if you guys know first.
I love quadratic formula.
Okay. X equals opposite of b
So, 2,
plus or minus the square root
negative
squared minus 4 times
2,
1
negative
negative 4.
2, 1.
So I get 2 plus or minus the square root of 20 over 2. What can you do with the square root of 20?
You can break it down.
We could break 20 into 4 and 5. Square root of 4 is 2. And then, so I get 1 plus or minus radical 5. Okay, it's not a pretty number, but that is a real number, isn't it?
Yes, it is.
Why don't we graph real quick and see what this looks like. I don't want to graph the original because it didn't have 0, but let's graph the next step. Really, or would you guys prefer to graph the one after we got rid of negatives? It doesn't really matter.
If it doesn't matter, then I'm fine with whatever.
Okay, so I'm going to graph the one I highlighted. So I got this. This point here is my 1 minus radical 5. This would be my 1 plus radical 5. Thanks. The one I graphed was less than 0. When is that less than 0?
After those points.
Those points. If you had graphed a 1 once you got it positive, all that would have done is flipped your inequality, and then you would have been looking for greater than 0, so you're still looking for the same pieces. Ooh. You put times right here. Okay. So my interval notation then. I want this piece and this piece. So it would be negative infinity. It did have an equal to. So 1 minus radical 5 with a bracket. Union bracket 1 plus radical 5, comma, infinity. So they don't always have to be nice, pretty numbers. We prefer it, but it doesn't have to happen. Yes?
Why would we use the x squared minus 2x minus 4 is greater than or equal to 0?
If you graphed this one, that's the one you would use. And if you graphed that one, your graph would look like this. My marker's dead. And then the greater than 0 would be this piece and this piece. So you get the same answer. So whichever one you graph, use that inequality. Yes?
Why? Okay, I thought this was no question. Why did you go down? It's like, why did you use that? Is it because the line system?
Why did I use this
Because
piece?
it's greater than.
Because I graphed this green one right here, and that green one was less than.
Okay.
So for the one I graphed, I wanted the part that was less than.
So if we just graph the positive one?
Uh-huh.
Would it be wrong?
No, because if you graph this one right here, it wants greater than. So what it would have done is flipped it. Greater than would be the same two pieces.
Oh.
So you'll get the same answer. Okay, other questions?
Whoa, that's so
Okay, almost done. Thank you. Last slide here. X squared minus 2x plus 1 greater than 0. So first, we always prefer box method if it works. It's a 1x, so we could do that. Is there anything that multiplies to 1 and adds to negative 2? Negative 1 and negative 1. If you set each of those to 0, you just get x equals 1 for both of them. So what that means is we have a graph and it only hits the x-axis once. Well, it's still a parabola.
Oh, wait, there we go.
Yeah. Should look like this. And you could always use your graphing calculator to confirm if you need to. Now, if my question was greater than or equal to 0, my answer would be negative to infinity. But I only want the part where it's greater than 0. It's greater than 0 here and here, but what happens at 1? Yeah, because it didn't have the equal to, I can't include the point where it does equal 0. So that's my only answer. Okay. Doing okay? Last question. In relation to this graph, how many solutions are there to the equation f of x equals 3? F of x is the same as what variable? Y. Y equals 3 is what kind of line? Y equals this horizontal. If I drew in that horizontal line at 3, how many times does it hit my graph? 0.
Oh, I thought you meant.
2.
I thought you meant that.
Oh. I wanted to know how many times that line would hit my parabola. So it happens twice. So I might ask you some questions like that. How many solutions would there be to the equation f of x equals 0? 1. What if I said f of x equals negative 1? 0. Okay. Is this good for everybody? I'm done. There's a Math Excel assignment for this day 4. Open today, due by 3 o'clock tomorrow. You've got time to work.